So this video is going to just go through the process of writing a formula for an ionic compound. There are some sections in the textbook which is available on Jack Plus but also on the dash page. There's a section on page 175 which actually goes through the process of writing formulas for ionic compounds. Okay, in that section there is a little description, and there's also the valency table, which is a modified one, a smaller one with just some of the key positive and negative ions. There is also a section earlier in the book here when it talks about, oh no, not that. Here when it talks about losing and gaining electrons to create a stable outer shell. So it talks about ionic compounds here, and again it's just got a list of the common positive and negative ions and their names. So that's on page 163 to 165. So I'm going to use that little modified table and I'm going to write the formula for calcium chloride. Okay, we know that the first one, calcium, is a metal, and therefore it's going to be a positive ion because it loses electrons easily because it has not many in its outer shell. So I find calcium in my valency table and I can see it's there. It has a 2+ charge. So I'm going to write the symbol for calcium, and then just above in the space, this is my kind of working space. Now you could just do this roughly and then write it out properly. You could just have that charge in your head. It's up to you. So calcium has a 2+ charge, then obviously the other part of this compound will be negative, and it's chloride, and it has a 1- charge. So I put the other symbol for calcium chloride, and I put 1- at the top. Now we know that the compound needs to be neutral in charge, so it can't have an excess of positive or negative ions. It has to be equal. Obviously at the moment it is not equal. It's got too many positive charges. So what I need to do is adjust the number of chloride ions so that the charges are equal. So I want 2-, so I'm going to need 2 of those chloride ions. And to show that I have 2, I write a little 2 there. Now technically, if you have 1, you could write a 1 there, but we just don't put a 1 there. We just assume that if there isn't a number, it's a 1. So my chemical formula would be CaCl2. Okay, that's showing that I have 1 calcium ion, or 1 atom of calcium, and 2 atoms of chlorine to make that a nice neutral compound. Using a little puzzle technique, I could draw my calcium ion, which is Ca2+. So those 2 pokey out bits of the puzzle are the pluses. I could draw my chloride ion. That's a 1-, so it has 1 inny bit of the puzzle. Now you can see when we're making puzzles, just like when we're making ionic compounds, we don't want any missing pieces or gaps. So to fill that gap, I need an inny piece, not an outy piece. So I just get a second one of my chloride ions. And then when I put all of that together, I would have a nice complete puzzle with no gaps. Okay, and that creates my neutrally charged, that's not really a thing, my neutral ionic compound. So this is the process that you use to write ionic formulas, or formulas for ionic compounds. Okay, and you could do the same. I'll do a little quick one. Let's do sodium sulfate. Flip it over. So sodium sulfate. I go to my ionic table and I can see that sodium is 1+ and sulfate is a molecule ion, so it's got 2 different elements in it. We bracket that and it's got an overall charge of 2-. So Na is 1+. Sulfate, I'm going to put it in brackets just to be safe and to show you that it's the overall charge of this molecule ion. At the moment, 1+ and 2-. Clearly it's not neutral, So I'm going to need 2 sodiums so that I cancel out the 2 negatives. And to show that I have 2 sodiums, I write a little 2 there. Now you could write it out like that. Okay, or at this stage, if you leave the brackets, I'm okay with that. Okay, it might help you later on down the track. Either or at this stage. There you go. Hope that helps.